Hey guys, Steve here with episode 2 of Pokémath. Today we'll continue to look at probabilities related to coin flips in the Pokemon trading card game. Now, recall from last week, we went over the probabilities for 1, 2, and 3 coin flip attacks. This week, we're going to check out attacks that tell you to flip until you get a tails. Now, this episode is much more complicated than last week's, so if you need to rewind the video or take a break to let things sit in, feel free. The flip until tails is a relatively common attack type in the game. For example, Raichu from Heart Gold and Soul Silver has one of these attacks. Its attack, Iron Tail, lets you flip a coin until you get tails, then multiply the number of heads by 30 to get the final damage. Recall that a coin flip has two possibilities: heads or tails. Once again, H is heads, T is tails. And there's a 50% chance, or 1 over 2, of each occurring. So when you flip a coin once, there's a 50% chance of it being heads. Now also recall that when you flip a coin twice, the probability of both coins being heads is 25%, or 1 in 4. Sorry, that's 1 over 4. And when you flip a coin 3 times, there's a 12.5%, or 1 over 8 chance of all 3 being heads. Now, there is a trend with all of these probabilities in their fraction form here. With one coin flip, 1 heads has a 1 over 2 chance. With 2 coin flips, 2 heads has a 1 over 2 times 1 over 2 equals 1/4 chance. With 3 coin flips, 3 heads has a 1 over 2 times 1 over 2 times 1 over 2 equals 1 over 8 chance, and so on, of course. And we can simplify these. 1 over 2 times 1 over 2 equals 1 to the second over 2 to the second equals 1/4. Furthermore, 1 over 2 times 1 over 2 times 1 over 2 equals 1 to the third over 2 to the third, which equals 1 over 8 again. Now, just to note, the small numbers above the large numbers are known as powers. They are used when you multiply a number with itself numerous times. So, in these examples, 1 over 2 equals, 1 to the second equals 1 times 1, which equals 1. And 2 to the second equals 2 times 2 equals 4. The same goes for 1 to the third equals 1 times 1 times 1, which equals 1, and 2 to the third equals 2 times 2 times 2, which equals 8. Now also note that 1 over 2 equals 1 to the first over 2 to the first, which equals 1 over 2. Because 1 to the first equals 1, and 2 to the first equals 2. So, this trend can be generalized. For any number of coin flips, which we'll denote as n, there is a 1 over 2 to the nth power chance of flipping all flips being heads. So, let's say you wanted to find the chance of flipping all heads with 4 flips. Quite simply, you replace the n here with 4. So we have 1, oops, that's a 2. 1 over 2 to the 4th, which equals 1 over 2 times 2 times 2 times 2. You can't read that, but trust me. Equals 1 over 16, which is about 6.25%. The same method is used if you want to flip, say, 10 coins. So we have 1 over 2 to the 10th,
which equals 1 over 2 times 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 2, 1, 2, 3, 4, 5, 6, 7, 8 times 2 times 2, which equals 1 over 1024, which is about, that's not right, 0.098%. So where am I going with all these calculations? We can use this formula, which I'm going to rewrite here, 1 over 2 to the nth power. We can use this formula that we've created to find the expected number of heads, or the expected value that you'll recall from last week's episode, for the flip until tails problem. Now we multiply the probability of all heads by the number of flips, then add all these results together. So it looks something like this. We have 1 over 2 times 1 plus 1 over 4 times 2 plus 1 over 8 times 3 plus 1 over 16 times 4, and on and on. And this goes on to infinity. Now, we can write this as, get ready for some heavy math here, the summation, that's what that sign means, from 1 to infinity of 1 over 2 to the n times n. This means that we take each term of the equation up here and add them together. Basically just like this, except this is much more compact than doing all this and then writing ellipses or even writing further on, which would just be ridiculous. Now, of course, it would be impossible to add an infinite number of equations together, so we can use some advanced math to find the answer. Or, in this case, we'll just be lazy and use a calculator, which is what I'm going to do. Maybe I'll go over the calculation someday, but don't expect that. So, after putting this equation into an advanced calculator, we find that the answer is 2. So you would expect to flip 2 heads whenever you did a flip until tails. Now, referring back to the Raichu example, you would expect to do 2 times, sorry, let me focus there, 2 times 30, which is 60 damage. Now, once again, this is not guaranteed damage that you would do, it is merely the average of damage you would do over time.
Now those were some intense calculations. So what can you, the Pokemon player, gain from all this? Basically, for all the flips you do, you would average out to about 2 heads. Consider, however, that for each flip until tails, there's only a 25% chance of flipping 2 heads, so it is far from expected. In fact, right from the beginning, there's a 50% chance of flipping tails, thus doing 0 damage. So, overall, the flip until tails is just slightly better than the 1 coin flip, but vastly inferior to the 2 or more coin flips. So thanks for watching today's episode of Pokémath, guys. I hope you learned a bit about probability in the Pokemon trading card game, and if you have any questions, feel free to send me a message or leave a comment below. Tune in to next week's episode, where I'll be going over a different mathematical topic related to the game. Thanks for watching, and I'll see you next time.